Good evening, sir. My name is Talin Savancha, and the topic for the assignment is Explain ZigBee. Let's come to the introduction. ZigBee is a wireless technology developed as an open global standard to address the unique needs of low cost, low power wireless IoT networks. The ZigBee standard operates on the IEEE 802.15.4 physical radio specification and operates in unlicensed bands including 2.4 GHz, 900 MHz, and 868 MHz. The 802.15.4 specification upon which the ZigBee stack operates gained ratification by the IEEE in 2003. The specification is a packet-based radio protocol intended for low-cost, battery-operated devices. The protocol allows devices to communicate in a variety of network topologies and can have battery life lasting several years. ZigBee is a low data rate, low power applications and is an open standard. This theoretically enables the mixing of implementations from different manufacturers, but in practice, ZigBee products have been extended and customized by vendors and thus plagued by interoperability issues. In contrast to Wi-Fi networks used to connect endpoints to high-speed networks, ZigBee supports much lower data rates and uses a mesh networking protocol to avoid hub devices and create a self-healing architecture. Let's come to architecture. ZigBee system structure consists of three different types of devices such as ZigBee coordinator, router, and end device. Every ZigBee network must consist of at least one coordinator which acts as a root and bridge of the network. The coordinator is responsible for handling and storing the information while performing receiving and transmitting data operations. ZigBee routers act as intermediary devices that permit data to pass to and fro through them to other devices. End devices have limited functionality to communicate with the parent nodes such that the battery power is saved as shown in the figure. The number of routers, coordinators and end devices depends on the type of network such as star, tree and mesh networks. Physical layer. This layer does modulation and demodulation operations on transmitting and receiving signals respectively. This layer's frequency, data rate and number of channels are shown below. MAC layer. This layer is responsible for reliable transmission of data by accessing different networks with a carrier sense multiple access collision avoidance (CSMA). This also transmits the beacon frames for synchronizing communication. Network layer. This layer takes care of all network related operations such as network setup, end device connection and disconnection to network, routing, device configurations, etc. Application support sublayer. This layer enables the services necessary for ZigBee device object and applications objects to interface with the network layers for data managing services. This layer is responsible for matching two devices according to their services and needs. Application framework. It provides two types of data services as key value pair and generic message services. Generic message is a developer defined structure, whereas the key value pair is used for getting attributes within the application objects. ZTO provides an interface between application objects and APS layer in ZigBee devices. It is responsible for detecting, initiating, and binding other devices to the network. Operating modes. ZigBee two-way data is transferred in two modes, non-beacon mode and beacon mode. In a non-beacon mode, the coordinators and routers continuously monitor active state of incoming data, hence more power is consumed. In this mode, the routers and coordinators do not sleep because at any time any node can wake up and communicate. However, it requires more power supply and its overall power consumption is low because most of the devices are in an inactive state for over long periods of the network. In a beacon mode, when there is no data communication from end devices, then the routers and coordinators enter into sleep state. Periodically, this coordinator wakes up and transmits the beacons to the routers in the network. These beacon networks are work for time slots, which means they operate when the communication needed results in lower duty cycles and longer battery usage. These beacon and non-beacon modes of ZigBee can manage periodic, intermittent, and repetitive data types. Topologies. ZigBee supports several network topologies. However, the most commonly used configurations are star, mesh, and cluster tree topologies. Any topology consists of one or more coordinator. In a star topology, the network consists of one coordinator which is responsible for initiating and managing the devices over the network. All other devices are called end devices that directly communicate with the coordinator. This is used in industries where all the endpoint devices are needed to communicate with a central controller, and this topology is simple and easy to deploy. In mesh and tree topologies, the ZigBee network is extended with several routers. The coordinator is responsible for starting them. These structures allow any device to communicate with any other adjacent node for providing redundancy to the data. If any node fails, the information is routed automatically to the other device by these topologies. As the redundancy is the main factor in industries, hence mesh topology is mostly used. In a cluster tree network, each cluster consists of a coordinator with leaf nodes, and these coordinators are connected to parent coordinator which initiates the entire network. ZigBee Alliance. The ZigBee Alliance works to simplify wireless product integration to help product manufacturers introduce energy efficient wireless control into their products faster and more cost efficiently. Alliance members create standards that offer reliable, secure, low power, and easy to use wireless communication using an open standards development process to guide their work. The Alliance is organized by committees, work groups, study groups, task forces, and special interest groups. There are three types of membership with different rights and benefits. An adopter offers access to final approved specifications, participation in interoperability events, and access to standard work task, group documents, and development activities. A participant offers voting rights in work groups and has early access to all ZigBee Alliance standards and specifications in development. Promoter offers automatic voting rights in all work groups, final approval rights on all standards, and a seat on the Alliance Board of Directors. Applications. Industrial automation. In manufacturing and production industries, a communication link continually monitors various parameters and critical equipments. Hence, ZigBee considerably reduces this communication cost as well as optimizes the control process for greater reliability. Home automation. ZigBee is perfectly suited for controlling home appliances remotely as a lighting system control, application appliance control, heating and cooling system control, safety equipment operations and control, surveillance, and so on. Smart metering. ZigBee remote operations in smart metering include energy consumption response, pricing support, security over power theft, etc. Smart grid monitoring. ZigBee operations in this smart grid involve remote temperature monitoring, fault locating, reactive power management, and so on.